So what is ensemble modeling?
Basic ensemble modeling is a technique where we use multiple models so that we can improve the overall accuracy a little bit. For example, if I take regression, if I take logistic regression or decision trees, these are like single models. They may not have all the flexibility to learn each and every pattern in the data. Using this ensemble technique, we can collate multiple models. So I can build multiple regression models and then collate their results to give me a better accuracy. I can build multiple decision trees, collate their results to give me a better accuracy. This is known as ensemble model building. So one of the ensemble model building technique is bagging. A special case of bagging is random forest. Another ensemble model building technique is boosting. So we can use gradient boosting method to improve the accuracy. And it has been proven both theoretically, practically, that ensemble models give slightly, definitely 2 to 3% accuracy better than the single model, or sometimes the accuracy is much higher also.
Okay, so what are the feature engineering techniques that you have used?
So some of the feature engineering, like one of the most widely feature engineering technique that I always refer to is one-hot encoding. If I have a categorical field, converting it into multiple columns, which is also known as dummy variable creation. That is one of the one. The other one that I very frequently use is this binning technique. So I use binning. If there are date variables, I extract month from there. Usually I extract quarter from there. Okay. If I have longitude, latitude variable, I can extract city, I can extract province, depending on whatever is the problem statement. But usually I work with most of the feature engineering that are related to binning as well as this one-hot encoding. Most of the times they serve my purpose.
Okay, so what are the hyperparameters in machine learning models and how do they differ from model parameters?
So if you take a machine learning model, typically a parameter means something that a model calculates. If I take a regression model, y equal to beta naught plus beta 1 x. Beta naught and beta 1 are known as parameters. Now these parameters are not in my hand. I can only give x and y data. The regression model or the machine learning algorithm will decide what is the beta naught and beta 1 value. So parameters are not in your hand. Whereas hyperparameters are in your hand. Hyperparameters are not there in every machine learning model. If you take a random forest model or if you take a decision tree, you can decide what is the depth of the decision tree. That is in your hand. By giving a lesser depth, you can make the decision tree smaller. By giving a larger depth, you can make the decision tree a very large one. So that is a hyperparameter. Hyperparameters are those values that will decide the complexity of your model. So some of the examples are in random forest. The hyperparameters are a number of trees and the number of what is the number of features that you can select in each of the tree, what is the max depth in each of the tree in random forest. In boosting, the learning rate is, or the shrinkage is one of the hyperparameter, or the number of iterations is a hyperparameter. Basically, hyperparameter is in your hand. You can modify it. You can change it. The model complexity will change. Parameter is not in your hand. It will be calculated based on the data that you have given. That is the major difference between parameters and hyperparameters.
What are the common challenges you might have encountered while developing a machine learning projects from a large data set?
So one of the biggest issue, or let's say there are several challenges that we encounter depending on the type of the machine learning model that we are using. The initial challenge that comes to us is the problem with the data. The first challenge that presents itself is there are outliers in the data, there are missing values in the data, and there are unique issues for each of the column. Maybe one column has 2% outliers, one column has 3% outliers, another column has 5% missing values. Column by column, variable by variable, we have to look at each and every variable. We cannot just simply overlook any of them. They may have a huge impact on my model at the later point of time. So the first issue that comes is in the data exploration, validation, cleaning phase. So once we clean all that data, once we build the model, during the model building phase, the biggest challenge that comes is sometimes the data that we have, the variables may not have the complete information. They may not have the predictive power. I have the data, that's all right, but it is not giving me the accuracy that I'm looking for. The model is not as good as that I thought of. And there's no way I can go back to the data team and ask for more columns. I have to manage the same columns that are there in my hand. So I may have to try various feature engineering techniques to improve the accuracy. And it's not that simple that I just try a feature engineering technique, it is giving me better accuracy. So the second challenge that I generally face is with the data, how do I improve the accuracy? Then the third challenge that comes usually is once I get a decent, good model, the model tends to get into overfitting sometimes. Overfitting, underfitting is another issue. Okay. So that is the final challenge that generally comes, like where I have to try various hyperparameters, try various fine-tuning techniques to make sure that my final model is working well on the trained data as well as working well on the test data and the validation data perfectly.
Okay, do you think that data processing is important for machine learning?
If you ask me, data processing is the most important step, because no matter how great a machine learning model can be, it learns the patterns from the input data. If the input data is totally junk, no matter how great the machine learning model is, the final output will be junk only. So a machine learning model actually starts before even you start a machine learning model. It starts with the data cleaning or data exploration, validation cleaning. That is a very important step. There can be few outliers that may turn your whole analysis upside down. We may end up giving loans to bad customers if we do not do the data cleaning and rejecting all the applications of good customers. Data pre-processing, data preparation for analysis is as important as the actual analysis.
Give a few examples of the processing steps.
So some of the, like, there is a particular step-by-step procedure that we follow while dealing with the data pre-processing. Once the data comes, you divide the whole data into two different type of variables, because when you are exploring these variables, it's not the same technique that you have to follow for every variable. You divide the variables into continuous variables, which are like income, expenses, etc. The second set is discrete and categorical variables, number of loans, 0, 1, 2, 3, or the customer's job type, blue collar, government, or self-employed, like that. So if the data is continuous, then we go for box plots and percentiles to detect the outliers. If the data is categorical, then we go for frequency distributions or frequency tables. Then we identify the outliers. Once the outliers identification is done, based on the percentage of issues, if the issue is less than 10%, then we go for imputation. If it is 10 to 20% or 20-25%, then we go for imputation as well as flag variable creation. If it is more than 50% issue, then remove that variable, keep only that flag variable, whether the data is available or not, whether the column is available or not. If the column is categorical, if there is an issue in the categorical data, then that particular category, if you want to impute it based on the target variable, we do the target variable based imputation.
Okay, have you worked on the tuning of a machine learning model?
So mostly I worked on the tuning of the random forest and boosting machine learning models for the decision tree as well. Okay, for logistic regression, linear regression, there is not much of fine tuning required. Yes, for decision tree, it is a must. I have worked on decision tree fine tuning. The fine tuning parameters or the pruning parameters are max depth and the maximum number of leaf nodes. If max depth is too high, then the model will be, overfitted. If the max depth is too low, then tentatively it may get underfitted. We have to fine tune and find that optimal point where the model is neither overfitted nor underfitted.
Thank you so much, Venkat, for answering all such questions that I asked you about machine learning and advanced analytics techniques. So we have finished this session here. I hope this video will help maximum people going further. They should know how to go for articulating their answer to such questions, and they should be able to crack the interview further. Thank you so much for everyone watching these videos with us.
Thank you. Thank you.